Yeah, and so this is why eclipse observations and eclipse chasing is so critical, because even though they happen often and even though we know exactly when they're going to happen, you never know when the weather will just obscure your view. So we want to take every opportunity we can to get observations.
Definitely.
So, okay, so if you were in Iceland and you were either seeing clouds or you were able to see the eclipse, please share your experience with us. We want to know what you experienced on the ground. Please tag @NASA wherever you're watching. So we have a lot of questions coming in here from social media. So Kelly, shall we dig into those questions?
Yes, let's dig in.
Alrighty, so we have Bo on Facebook and they ask, are we really going to lose gravity during the eclipse?
No. We are not.
Okay.
Gravity, really, the stuff that sticks us to the Earth's mass has not changed because of this eclipse, and so we're going to stay grounded on this Earth.
Okay, noted. Gravity will not change. Okay, so we have another question from X, and they ask, how much can we actually learn about the sun during just a few minutes of totality compared to years of normal observations?
It's really about having all of the observations, right? We definitely need that totality because the moon just happens to fit so perfectly over the surface of the sun that we can see from that surface outward for that space weather, whereas some of our instruments aren't quite that close in. So we need to knit them together and use both the couple of minutes from the eclipse as well as the years of observations from our NASA satellites.
Okay, well, I'm glad that we have both ways of getting observations.
Exactly.
So we have another question here from Elinu on YouTube, and they ask, why does the weather change in a solar eclipse?
That's a good question, and I think that's something still trying to be understood. But if you imagine you've stopped heating something up temporarily, so things sink, right? When things get cold, they tend to sink, and so the air is moving, and there starts to create winds. And when you create winds, you start to cool things down. So the weather changes due to just turning on and off the light alone, because the sun is so important to us in actually regulating our weather.
Wow. Okay, so we have another question here from Frank Perez on X, and they ask, for sending teams to do research in the path of totality, how do you balance the crew training value of Iceland's terrain against the statistical odds of clearer skies in Spain?
And we definitely addressed both, right? There are great things to do with the atmospheric work, especially in the Arctic areas, for the balloons that we sent to Iceland, and then we have teams in Spain also doing that. So it was a balanced portfolio. We made sure that we had both types of experiments available.
Okay. Thank you so much. So keep your questions coming in. We'll be answering more later on in the show. And so earlier, I also mentioned that we had questions for you, the viewers, as well. You can head over to NASA's Twitch and Instagram to weigh in on a couple of those. So here are some of those questions that we posed to you. So Kelly, let's see what those questions are.
Definitely.
So if you had to pick where you'd watch the eclipse from out of these special locations listed,
yes.
I'm going to ask you this, Kelly. Which ones would you choose? So we have the International Space Station, a high-altitude plane, an observatory telescope room, and a NASA chase jet.
It would be a tough choice between International Space Station or high altitude plane. They've got such a huge overview. It's great.
Yeah, I think I would choose the same too.
Yeah.
So thank you to everyone who has participated so far. We're going to check back into those results a little bit later on. So next, let's head back to the ground in Iceland. We have another NASA-funded experiment there involving balloons. Students that are part of the nationwide Eclipse ballooning project. They've been launching balloons continuously throughout the eclipse, and we're going to be chatting with them live from Iceland shortly. But first, let's learn more about their Eclipse project.
Teams of students from across the United States have a unique vantage point of total solar eclipses, thanks to scientific balloons.
The Nationwide Eclipse Ballooning Project is a NASA mission-like adventure in collecting data from balloons that go high up into the atmosphere.
Started in 2014, the project engages college students and high schoolers in one of two distinct paths.
One is the engineering track that has mostly engineering students that get to tinker on different payloads. And the other track is an atmospheric science track where they'll actually be launching weather sensors to study the impact of the eclipse.
Atmospheric science teams launch helium-filled weather balloons, the same as those used by the National Weather Service, every hour for hours before and after an eclipse. Engineering teams fly larger balloons laden with cameras and experiments they build themselves 100,000 feet up into the stratosphere. From there, they study a variety of things such as incoming cosmic radiation and ozone levels, as well as offering dramatic views of the moon's shadow on our planet.
The project is really a unique one in that it's both an education, but also doing amazing science that's both about the eclipse itself and also the atmospheric response of the eclipse.
Student balloon teams made a historic first during the 2019 eclipse. They measured eclipse-driven atmospheric gravity waves in Earth's stratosphere, or large ripples in the air caused by the temporary cooling due to the drop in sunlight.
What excites me the most about this project is thinking about the experiences that the students have that they'll remember forever.
Talking to us live from Mosfellsbæ in Iceland, we have Jared and Tessa, who are part of the nationwide Eclipse ballooning project. Jared and Tessa, thank you so much for joining us. I know you just experienced the total eclipse in Iceland. How was that for you?
It was awesome. I mean, it's definitely cloudy here, which is a shame, but we saw the lights dim. It was almost as if you were indoors and it was just, you were dimming the lights. It was almost instant, which is, I've never been in the path of totality before, so I've never seen anything like that. So it was really amazing.
Yeah, the wind totally stopped. It was windy and then it just stopped. The birds, we had birds flying over us all day and then they just disappeared. So it was a little eerie, kind of creepy.
Wow, that's amazing. I'm so glad that you could experience that, even though, you had cloudy skies. So tell me more about what you've been doing. I see you've got balloons launching in the background. What are you measuring with the balloons in Iceland?
So we have 7 balloons that are measuring a lot of different things like temperature, pressure, humidity, wind direction, and speed. And this is supposed to gather the atmospheric changes during the eclipse. So normally during the day, air rises until it hits less dense air, and this is called the boundary layer. But during nighttime, when the sun is down, this air stops, and it's called boundary layer collapse. So that's exactly the same thing that happens during the eclipse, and we're using these radiosondes to measure the atmospheric changes, the boundary layer collapse, and then the recovery. And we're in Iceland not just because it's in the path of totality, but also its northern latitude and its shorter nights make a completely different boundary layer. So it's been a really cool opportunity to be able to study that under the eclipse, under this unique conditions.
So you're both college students right now. How long have you been part of the project, and what made you want to join the project?
Yeah, so we started this project at the beginning of June. So we've been working with our teams, respective teams, Tessa at the University of Kentucky, and then my team made up of students from across Idaho. And we've been meeting once a week, doing balloon launches, preparing, and really what got me into it was my ballooning club that we have at the University of Idaho, and we all just, we love the science, we love the teamwork, the team building, and so it's been a lot of fun.
That's great. And so do you have any tips for students who are thinking about joining?
Yeah, so my biggest tip would be to get involved. That was how I learned about this project, was through my club. The professor came to us and was like, hey, there's this really cool opportunity, and so you guys should put an application in. And then also just, if you have internship opportunities and you see those, just put an application in. You never know what opportunity you could get.
And then also, I would say, if you have a class that you're really interested in, just talk to the professor, see if they need any help on the research, because it really gives you a good opportunity to apply your classroom knowledge to real life scenarios, which you don't usually get in the classroom. And you also never know what opportunities will arise, like going outside the country for the first time, like I'm doing right now. So, yeah.
Oh, wow, that's amazing. Well, best of luck. I know you're launching continuously after the eclipse as well. So thank you so much for joining me, Tessa and Jared.
All right, thank you.
So the nationwide Eclipse ballooning project are also launching balloons in Spain as well as Iceland, and I can't wait to see their observations. So if we head back to the map, the moon's shadow is heading towards Spain right now, and we're roughly half an hour away from totality in León, Spain. For this eclipse, the moon's shadow is roughly 182 miles wide at its maximum width, and it's traveling at over 2,000 miles per hour. And so here we're seeing eclipse views as well in the bottom corner in León, Spain. And you can see the little bite that the moon has taken out of the sun, and we can't wait to see totality there. It looks like they have clear skies, which is awesome. And so if you are watching the solar eclipse from the ground, remember to wear safe solar viewing glasses or eclipse glasses, like these ones here. The only time you can take them off is during totality when you're experiencing it. If you're watching the partial eclipse in the United States, you can wear eclipse glasses the entire time. If you want to learn more about eclipse safety, head to science.nasa.gov/eclipses. So total solar eclipses give us a chance to study the sun's corona in greater detail, which helps us learn about how it behaves and affects us here on Earth. The sun is highly dynamic and creates conditions in space called space weather that can affect our technology, from GPS systems and communication satellites and airplanes and even our power grids on the ground. But in order to better understand it, we have a suite of spacecraft that are monitoring the sun from different vantage points around the clock. So let's learn more about NASA's space weather program.
Across our planet, billions of people depend on the invisible networks that connect us to space. Every day, those networks are at the mercy of our temperamental sun and the space weather that it unleashes across our solar system. That's why NASA's space weather program tracks solar storms from the moment they erupt, modeling their paths, anticipating their impacts, and leading the research that the world's industries rely on. NASA's space weather research and modeling is driven by the needs of society and enables critical decision-making that equips pilots to reroute around high radiation areas, farmers to adjust GPS-based precision planting and harvesting plans, and power grid operators to mitigate the impacts of potential surges. For those exploring other worlds, NASA provides 24/7 space weather monitoring for Artemis crews at the Moon and future Mars astronauts who may be exposed to dangerous levels of radiation during solar storms. Whether you're a pilot or a passenger, a farmer or a consumer, a power grid operator or energy customer, a satellite controller or GPS user, space weather impacts us all.
If you're just joining us, welcome to NASA's live coverage of today's total solar eclipse. We're roughly about 25 minutes away from hopefully seeing the first instance of totality in Spain. So stay tuned for that exciting moment. And so joining me in the studio now is one of NASA's space weather analysts, Karina Alden. Karina, thank you so much for joining me.
Thanks for having me.
So your role involves monitoring the sun in real time. Can you talk a little bit about what you do?
Yes, of course. So what we do is we basically observe, model, analyze, and then we document it. And so what we're observing is usually those coronal mass ejections, or as I lovingly like to call them, sun burps. And we're measuring those, seeing where they go, and then we're modeling them to see what NASA missions or possible planets they impact. And then from there, we're documenting it and notifying NASA missions about potential impacts.
And so we just learned a little bit about NASA's space weather program. How does monitoring space weather affect the everyday person?
Yeah, so most of the time the everyday person is going to see it in terms of northern lights, but what we do also see is some of that impact to the GPS as you're navigating. Sometimes it'll be a little wonky and you don't really know why, but that could possibly be due to some solar storming happening. And then we may also see some impacts to agricultural folks who are using tractor precision farming.
And so back in 2024, we saw these huge solar storms. Can you tell us how that storm affected Earth and if we had to mitigate any of those effects?
Yes, so along with NOAA's Space Weather Prediction Center, we did have to do some mitigation, but honestly, my favorite part was seeing the Northern Lights. And so 2024 is when I first got to see the Northern Lights. I saw them in August, and then you're seeing a picture that I took on my phone where we saw them here in Maryland, which was absolutely incredible. And you can see a picture of the team that I work with, the Moon to Mars Space Weather Analysis Office, along with some of the Heliocomms folks, where we got to see it down here in Maryland, which is absolutely incredible.
Amazing. And so I know that you're also part of the team that monitored space weather 24/7 during the Artemis II mission when we flew astronauts around the moon. What was that experience like?
Surreal. I mean, it's very odd to be staring safely at the sun via satellite imagery, but not see it in person for an extended period of time, because I was working the overnights, but it was incredible, and I loved seeing the solar eclipse from space. I think if I were to do it, I'd want to be one of those astronauts.
Absolutely. Well, thank you so much for joining us, Karina.
Thank you.
So next, let's hear from NASA Administrator Jared Isaacman and Head of NASA Science, Nikki Fox. My colleague Jasmine Hopkins caught up with them a few days ago to talk about why this celestial event is so important and what the 2026 eclipse can teach us about the sun.
Today, I'm thrilled to talk all things eclipse with NASA Administrator Jared Isaacman, who's leading our vision behind science and why eclipses are so important, and Dr. Nikki Fox from our Science Mission Directorate, who will tell us what exactly is going on with the sun during an eclipse. Are you guys ready to talk?
Absolutely.
Okay, fantastic. Our opening question is for both of you. Just a couple months ago, we wrapped up the historic Artemis II mission, and now we're on the cusp of a total solar eclipse. Can you describe in one word how you're feeling right now?
Excited?
He took my word.
Okay.
Excited is the right word, because when you saw that total solar eclipse from Artemis II, it was so spectacular and nobody was ready for it, even people who see total solar eclipses all the time. And so when you saw that, it just brought the beauty of space and the beauty of the science we do into such clarity.
I think NASA is one of the only places where we can see a solar eclipse from down here on Earth and then from the other side of the moon.
We study the sun all the time. It's one of our main things that we study in NASA science. We look at it in all different wavelengths. We look at it from all different vantage points to be able to predict when these really large radiation storms are going to come towards our planet, because we want to make sure our astronauts are safe. The eclipse just gives us even more opportunity to study that sun just a little bit more, to really make those big breakthroughs to keep our astronauts safe.
All right, next is for both of you. If you could witness a solar eclipse from anywhere on Earth, where would you choose?
Anywhere that doesn't have clouds. Having been clouded out for the last eclipse, I will say I will go anywhere that there's no clouds.
Look, Iceland is very cool in Spain, a lot of the observation locations for this one, but in Egypt, in the Valley of the Kings, is going to be an amazing backdrop.
And that is going to be the longest total solar eclipse of the 21st century. It is over 6 minutes. To stand in somewhere ancient is particularly moving.
What's the one thing you want people to walk away understanding about why studying eclipses matters?
I think these kind of magical events, I would very much describe that eclipse as a magical event. Maybe it creates a spark in who knows how many people around the world to look up, imagine what's possible, and then grow up and start contributing in this great adventure that we're on.
Remember that Einstein confirmed his theory of relativity using an eclipse. Eclipses are very powerful. You see stars, you see constellations, you see planets that you don't normally see. It kind of reminds you of our place in the universe.
Why do we still care so much about the sun? Is there anything new we can learn about it?
There's always new stuff to learn about the sun. It is our star, but it's the only star we know right now that has the responsibility for maintaining life on a planet. And as we sort of continue to try and answer the question of, are we alone in the universe? Understanding our relationship with our sun is so important, and eclipses give us that opportunity to do that. It is honestly the only time that we can really observe some of the phenomena, particularly down low in the chromosphere, really looking at how the corona turns into the solar wind. It bathes all of the planets, but we live in the atmosphere of the sun. So when you get these big events, they can cause havoc for technology here. And of course, our prime thing, keeping our astronauts safe in space. So understanding our sun is more critical today than ever.
Thank you both so much for being here today. Really appreciate it.
Thank you.
Thank you to our NASA Administrator, Jared Isaacman, and Head of NASA Science, Nikki Fox. Let's head back to Ernie right now, who is going to dive into our eclipse maps and where the eclipse is heading next.
Thanks, Joy. It's so exciting for me to watch this eclipse progress. I mean, we can predict these, but you really can't anticipate how you feel about them until you see them. So I'm standing in front of the eclipse map, and just to recap, this red stripe is the path of totality. Those are all the locations that can experience totality. You're seeing the partial shadow emerge from northern Siberia. It has already crossed Alaska. It's over Canada and the northern United States right now. And that little oval is the umbra where totality is actually taking place. It has just passed by Iceland, and although it was cloudy there, people got to experience the secondary effects of an eclipse where you get the darkening and the brightness along the horizon. And it will very soon be over northern Spain, where we expect more than 15 million people will be watching the eclipse. Toward the end of it, partial eclipse in Western Africa. So this is a close-up view. Reykjavik is here. They unfortunately had clouds, but the WB-57 was flying just above that. And they were there because that's kind of the spot that if you're on the center line, you get the longest eclipse of 2 minutes, 18 seconds today. And we're just a few minutes away from seeing totality pass over Spain less than an hour before sunset. That should produce some really beautiful photographs, especially for folks on the beach watching this over the mountains to the west. This is an unusual eclipse. It's kind of weird. And one reason for that is where the total eclipse starts. This is the Timir Peninsula in northern Siberia. And because they're so far north, that eclipse starts at midnight. They are well above the Arctic Circle, so the sun is up 24 hours a day. And then the other kind of odd thing about it is this north-south path. Most eclipse paths, most totality paths are west to east. But this one, because it's so close to the pole and because of the orientation of the Earth and the fact that it's a descending node eclipse, it's starting in the north and going to the south and then suddenly making this left turn into Spain. So we're looking forward to seeing that total eclipse in Spain where the weather looks great. Back to you, Joy.
Thank you so much, Ernie. So we're about 15 minutes away from totality in Spain. The view we're seeing here is from Leon, Spain. And I want to say thank you again to our partners, Time and Date, Southern Illinois University, and Exploratorium for providing these stunning telescope views of the solar eclipse. This is really, really exciting. They have 15 minutes left until the sun is completely obscured. Luckily, Earth is not the only place you can experience a total solar eclipse. Our astronauts on the International Space Station have witnessed several solar eclipses from this very unique vantage point. So let's learn more from my colleague Abby Unterante, who caught up with the astronauts on the space station a few days ago.
Well, hi, Jessica and Anil. It is so great to talk with you. From the International Space Station, you see Earth and the solar system from a unique perspective every single day. Thank you so much for joining this long-distance call to talk about this moment.
We're so happy to share this with you.
We study the sun and its influence on Earth and throughout the solar system through a field called heliophysics. What is the benefit of studying the sun from up there in low Earth orbit?
One of the big things is that there is a lot of particles that are around Earth, and those particles can be affected by coronal mass ejections, and those ejections can energize the particles and affect things that are in space. And the things that we care about in space are satellites, and those satellites give us communication, they give us internet, and so there's even a future where we have data centers in space, and we're using the sun's energy to power things like artificial intelligence and things like that. And so we need to understand how that's going to be affected by the sun.
If you could pick anyone, who would you want to watch an eclipse with, and would you rather watch it from Earth or from space?
This one for me just reminds me of one of my mentors from graduate school, Jerry Koyman, and he and his wife, they are eclipse chasers. So I think if I could share it with one very special person, somebody that played such a role in inspiring me and helping fuel my scientific curiosity and helping me be a successful scientist, it would be to watch that with Jerry, and it would be to watch it from up here, because I know he has never seen one from the International Space Station.
I was going to say something similar. I would love to watch it with my kids because it was such a unique experience for me. When it happened, the animals, the birds got quiet, it got dark, it almost felt cooler, and I think they would really love it.
Anil, I know you just arrived. Is there anything that you've seen out of the cupola or the wharf that surprised you since you've arrived?
Here's the most surprising thing. On the launch, you have a chance to look out of the window of the spacecraft as it's docking with space station. And when I looked out the right window, I saw this bright, shining thing, the International Space Station. I knew it should be there in space, and we were tracking it, and a lot of people did all the math and engineering to get us there, but it just was something that was just hard to comprehend at the same time and utterly beautiful. It's this merger between art and science.
The best part about that moment was we were all inside the space station, very anxiously awaiting Anil and Pyotr and Anya's arrival, and we could hear the communications coming from the Soyuz. The Soyuz was, of course, talking to the ground. All of a sudden, we heard Anil's voice, and he said, "I see it! I see the space station!" It just made everybody smile and made everybody so happy, because we remembered that moment for ourselves when you see it for the first time, and it doesn't even look real. It looks like a little computer animation or something, and it's so small, and then it just gets bigger and bigger and bigger, and then suddenly it becomes your new home.
Thank you so much. It has just been a pleasure to speak with you both. We really appreciate you taking the time.
Thank you, Abby. It's been wonderful speaking with everyone today. So keep looking up, and we'll be waving at you.
So at last report from Mission Control, Jessica, Anil and the rest of the crew had their eclipse glasses on standby, just in case the space station path brought them any unexpected views. So we'll keep an eye out and see if they saw anything. But we did just get something new come in. So a short while ago in Hodgdon, Maine, in the US, one of our NASA photographers actually caught the International Space Station flying across the sun during the partial eclipse. Let's take an exclusive look at that image. Wow, that is an incredible shot. So this was taken by Joel Kowski with NASA headquarters. So in the middle, you can see a tiny little speck, and that's the space station that flew right in front of the partial eclipse at 1:14 p.m. Eastern Time. You can see it along the middle here, and there are some cloud coverage. You can see the clouds kind of going in front as well, but this is a really, really beautiful shot. The space station was traveling at about 5 miles per second here, so our NASA photographer, Joel, would have had about half a second to capture this exact moment. In Joel's photographs, you can also see like the slither of the moon at the top corner as well, and the moon was covering roughly 20% of the sun. Although Joel is a very experienced photographer, anyone can take photographs of a solar eclipse. So next, let's hear a few tips on how to photograph one. sometime after the show, NASA will also be releasing exclusive eclipse images from Spain as well. This is where our NASA photographer Bill Ingalls is hoping to capture the eclipse near the horizon. We're about 7 minutes away from totality in Leon, Spain, which is so exciting. This is some of the crowds there that we're seeing. You can see that the darkness is looming. It's not quite totality there yet, but they are almost there, which is awesome. So now I'm joined here by NASA's Heliophysics Director, Joe Westlake. Joe, how are you feeling about today's eclipse?
Oh, super excited. Super excited to see it and to share our science, NASA science across the world.
So if you're watching from the ground and you don't have eclipse glasses, there are actually many ways to watch an eclipse. These are through indirect viewing methods. So Joe, do you want to walk through some of those methods with us?
Yeah, so these are super cool. This is stuff that you've got at home and things that you can use to help you view an eclipse safely without your glasses. So here we have just a standard colander, right? What you would have in your kitchen. Maybe clean some, berries or whatnot with it. And I'm going to demonstrate how you would use this to look indirectly at an eclipse.
Okay.
You're using the light of the sun as it would filter through this colander, and let's demonstrate together. Here,
okay,
Joy. So yeah, if you could hold that.
Do you need a piece of paper?
You don't need a piece of paper.
Okay.
You can just have it on the ground, something light that you could see.
Okay.
I've got a flashlight that's sort of demonstrating what an eclipse would look like. It's got a little piece of foam there that'll show. So let's shine our light. Let's do our sun, and then show it as it would hit the this colander. And what you can see there is these nice little crescent moon shapes, which are showing the eclipse on our example paper here. So that would usually be a bunch of circles, like if you took this out during regular daylight. Here in the US, you would see just a little sliver gone. Over in Spain, of course, they would see these beautiful little crescent moon shapes.
So you don't want to be looking through the colander, but you want the sun to be shining through it.
Absolutely.
Okay.
Right.
Gotcha.
You want to use this as your light filter for you. And the cool thing is you can use this, but you don't have to use this. There's lots of other possibilities. So you can actually take your hands, right, like this.
Okay.
Spread your fingers out.
Yep.
Hold them over top of each other. And you make little pinholes yourself when you do that.
Okay.
Right? And when you do that, you can actually see through and be able to see the eclipse in the same way, right? So that's a cool way to do it. And then on top of that, let's say you're taking a walk in the woods. Well, the leaves of the trees actually make these kind of pinholes all over for you as well. When they do that, you get this beautiful, constant crescent moons and everything everywhere. One of my favorite ways to see an eclipse.
Thank you so much, Joe. And so today's eclipse, August 12th, also lands on another special day. So on this day in 2018, NASA's Parker Solar Probe launched into space to study the sun's corona up close. Joe, can you tell us a little bit about that mission?
Yeah, what an incredible mission. This is humanity's opportunity to actually touch our star, right? We flew a mission, Parker Solar Probe. It's still up there. It's still operating. It's still taking great science. But it's flying within the corona, within what you see in the total solar eclipse, and taking direct measurements of that corona to help us understand how our sun works.
Amazing. So we have a lot of questions coming in from social media, and we have time for just one, Joe. Great. So let's dig in. Kyle asks, it seems to be that there are a lot more solar eclipses happening the past few years. Did something change?
Nothing changed. The geometry of the sun, the moon, the earth is the same. But one of the cool things about our technological society today is you get to see many more of these things, whether it be because of social media, because of, people have access to cell phones, or just the accessibility of travel and being able to go to these different places. I'm personally really glad that people are hearing more and more about eclipses because it brings the greatness of NASA science home to all of you.
Thank you so much, Joe, for doing this demonstration and for being with us here today.
Thank you so much, Joy.
So now let's head back to the eclipse map where we're going to see the eclipse in real time. So as you can see in the bottom part of this video, the moon's shadow is just about to reach Spain. We're about 3 minutes out from totality hitting Spain. Leon, Spain is going to be experiencing totality, and it will be getting about 1 minute and about 44 seconds of totality, which is so exciting. The path is going to be hitting several other towns as well, such as Mallorca and Villalobado. And the view that we're seeing right now is of Leon, Spain. And And even though totality hasn't occurred yet, you can see a tiny little filament, or prominence, sorry, on the one side. Okay, so remember to be safe when watching a solar eclipse. You have to be wearing safe solar viewing glasses or use an indirect viewing method when viewing when the moon hasn't completely covered the sun yet. You can only look at a total solar eclipse during totality when the moon is completely blocking the sun. So back in the studio, we have Kelly with us again. Kelly, what is it that makes this eclipse in Europe so special?
It really is so special because, again, this is almost at sunset. So we're experiencing something that's a little bit different, having it so low on the horizon. And look at those images there. You're seeing that darkness already coming in, those kind of sepia tones instead of the normal bright light or even the normal types of sunsets.
Wow, so we are 2 minutes away from totality in Spain. You can see the crowds in the bottom corner there, and this is the sun's view. Oh my goodness, so 2 minutes until totality, and we have a slither of the sun left. This is just amazing.
Yes, it's so beautiful. And like you were saying, there is that prominence there that we already see. So these are things that are very interesting and, again, can erupt in the space weather that we were talking about earlier. So this is a great view. And even with this, you know, it's not complete darkness. That little bit of sun still lights it up so that we can see the crowd.
Wow. So we're about a minute and a half away. What should people expect to see moments before totality hits?
So what they should see is what we call the diamond ring effects, or the Bailey's bead. So these will be really bright lights, and it's from the last bits of sun coming through the moon's valleys. So that will come through, and we'll see that. And you still need your eclipse glasses or an indirect viewing method at that point in time. But then once that's done and you're in the path of totality, it's time to remove those glasses and see the corona with your own eyes.
Wow. And if you're on the ground, what other sensations will you be feeling?
It will definitely be getting colder. There might be a wind. You could, again, change in animal behavior, any wildlife that's around you, and really the sense of awe, as well as the 360-degree sunset all around the horizon. So just a few things to look for.
Wow, this is a stunning, stunning view. We have just a slither left, and this is the moon covering the sun's disk. And when totality occurs, that slither will disappear. We're about 30 seconds away now from totality in Spain. If you're on the ground and you have clear skies, we are so happy for you.
Yes, definitely.
Wow.
It's just beautiful, and again, probably feeling so much excitement, and sometimes you even feel a little fear, like I think was mentioned earlier. They felt it was eerie almost. It's an eerie light. It's not something that we're used to in a human experience, but here it goes. It's we're getting close to those Bailey's beads or the diamond ring effect, so those should be coming very shortly.
Wow. All right, totality is almost there. The slither is about to disappear.
Oh,
okay.
The little diamond ring.
Wow.
Yeah. All right.
Totality has hit Spain.
Yes.
Oh my goodness.
Lovely view.
What is the red mark that we're seeing on the image right now of the sun?
So the red mark is that filament. So it's a bunch of very hot material that has been hanging above the sun and just kind of hanging out there based on the magnetic fields of the sun that keeps it kind of in a little magnetic cage. Oh, look at that. That's a really nice view of the corona. You're seeing things that look like streaks coming out of this, and those are streamers. So that's the basis of the solar wind that we are bathed in constantly. The sun is constantly outflowing material, and so that's that constant stream, and then you see the what could become a big chunk at some point in time in the pink filaments that you see there.
Wow. So we see that coming off of the sun. So this is the atmosphere of the sun's corona. Are those streaks that you just mentioned, are they coming towards Earth as well?
They are coming towards Earth. So they fill the entire solar system, or the heliosphere, which is actually all that the sun encompasses with that solar wind. So it's the entire solar system, so it definitely hits us here on Earth.
Wow.
And this is absolutely beautiful. Again, you're seeing a prominence also on both sides, really, and maybe even one up on the other corner.
Oh, wow, yeah.
So there's lots of, even though the sun is supposed to be towards a minimum of activity, which meaning you should see less of this, we're seeing more of it. And this is one of the important reasons why to keep studying these eclipses, is to see what is actually happening on our sun. When we think we know what's going on, it seems to change it up a little.
And what is it about these features that are so important to study?
It's important to study what they're made out of. Oh, and now we're back to the diamond ring. So we're coming back out of it already. It was always,
wow.
Yes, it happens so quickly. And once you see one, you definitely want to go back and see some more.
Wow. So totality has ended.
Yes.
In Villabado, Spain. Mm-hmm. Wow. So you're telling me that we also see the diamond ring and Bailey's beads at the end of the eclipse as well?
Yes, exactly.
Wow.
Where you're going into or out of the eclipses.
Okay, so this is a view from Valoria La Buena in Spain as well. They are seeing an eclipse right now. Eclipses happening in Spain are about a minute apart from one another in these telescope views. So they're seeing totality. So the red mark that we're seeing right now, is that another prominence?
Yes, those are prominences, that material that is suspended above the sun that's very, very hot. Again, it's interesting to us to know what they're made out of. There's normally filters, like here and on the airplanes as well, to tell us about whether that's some iron or whether that's carbon or oxygen or what exactly is those pink filaments made
of. And you can see the moon is moving away from the sun right now. What is it that we're watching?
Yeah, Bailey's beads, and so these are the beads, and so now we're actually going out of totality again. So
wow, what a brief moment of totality. Yeah. This is just amazing. They have had clear skies, and this is exactly what you want for a total solar eclipse. Yeah. Wow. This is Mallorca in Spain. Yeah. Oh my goodness, this is stunning.
Wow, yeah.
Look at that corona. Why is it so much clearer? Why is a corona so much clearer during a total eclipse?
Yes, yeah. So it's so much clearer because you're taking away all the bright light from the face of the sun. The sun is very, very bright. So it's basically 1,000,000 times different. And when you blot out that middle, you can see all the beautiful things that are going on behind it. And so, yeah, so this is the beautiful crescent moon that you're seeing. I think previously we were seeing those strikes of light. That's also closer to sunset there as you go more south in Spain. And already the light's returning, and they seem to be very excited in the crowd there.
Yeah.
It's such a great feeling to experience those eclipses, even though they were so short.
Wow. And experiencing a total solar eclipse, that is completely different to a partial eclipse.
It really is. And it took me, even as a whole heliophysicist, it took me a while for them to convince me that I should do it. And once I saw my first in 2017, I've seen multiple since, because it is a full body experience. It is very different than seeing just one bite out of the moon. The whole body experience and just the joy and awe and kind of your place in the world is so important to experience.
Absolutely. I'm for sure now an eclipse chaser. Well, that was an incredible solar eclipse. What a view. I am thrilled that their skies were completely clear, which means that we could see the sun's corona so clearly. And we could even see multiple prominences as well from the sun, which is a beautiful sight during an eclipse. Yeah. So in a few minutes, we're going to be speaking with a NASA astronaut live from where they saw a total eclipse. But first, let's go back to the poll that we posed to you earlier on in the show. So, Kelly, I know that you had answered some of those questions as well. Yes. So let's take a look at what our viewers thought about those questions. Okay, so let's head to one of the poll questions. But while we're kind of like waiting to get that set up, let's continue looking at this beautiful partial eclipse now in Mallorca, Spain.
That's just gorgeous. That is just absolutely gorgeous in terms of that very little sliver. Again, this is towards sunset. So normally if you're looking at a sunset, especially over water, you're seeing that kind of orange ball, red ball go down, and then you have this beautiful eclipse to happen. These really are just going to be spectacular images.
Yes, absolutely. Okay, so let's head back to the poll answers. Our viewers, so the first question was, where would you rather watch an eclipse from? You said the International Space Station, and our viewers would agree.
Yes, it'll be a party on the International Space Station.
I also wanted to be there too, so we're all going to be up there. The second question on the poll for everyone watching was, what would be your ideal eclipse watching soundtrack? And the options were cosmic lo-fi beats, dramatic space opera music, chill acoustic sky watching vibes, or just the sounds of nature and the crowds. And the winner was cosmic lo-fi beats
Oh, all right. Yeah, that's a good soundtrack. I can see that.
Yeah. I voted for opera music, but
yeah, and I might be a little bit more Sounds of Nature, but that's just me.
Okay. Well, anyway, thank you so much. So, although totality is over, the partial eclipse will still be visible for the next hour or so. Remember to stay safe while watching the rest of the partial eclipse by wearing eclipse glasses or by using an indirect viewing method. And so if you want to learn more about eclipse safety, go to science.nasa.gov/eclipses. Okay, so next we have a very special guest calling into the show live. NASA astronaut Don Pettit just witnessed the total solar eclipse from Alcañiz, Spain. Don, can you hear me? How are you doing?
I can hear you loud and clear, and I'm standing out in Alcañiz, Spain, just in awe from looking at the totality phase of this eclipse.
Wow, so how are you feeling? I know you just finished watching the eclipse. How are you feeling right now? What did you experience on the ground, and what did you hear? Were you surrounded by crowds at all?
The sky is exceptionally clear, and there's hundreds of people here, and that's part of the eclipse. It's not being off by yourself, it's being with a group of people, the people that live in Alcañiz, the group of people that I'm here with, and experiencing this amazing celestial event all together.
Amazing. So people might know you for your incredible photos and videos from your multiple trips to the International Space Station. Did you take any photos during this eclipse, or did you put your camera down for this one?
Oh, no. What I do is the same thing for launches. You set a camera up on automatic, and you get whatever you get from the camera, and then you stand back and you watch the launch or you watch the total eclipse. They're both kind of in the same category in that they only last a couple minutes in terms of what you could see, and it's better to view them through your own two eyes than through the viewfinder on a camera.
Okay, good tip from a NASA astronaut. So how did the experience watching this from the ground compare to watching an eclipse from space, which I know you've done a few times?
I've had the opportunity to see two solar eclipses from space. And in space, you look at the shadow projected on Earth. You don't look at the sun itself. And the shadow has all the detail that the classic astronomers from hundreds of years ago predicted. You see the umbra, you see the penumbra, you see the shadow moving over Earth, and it's a vantage point from space that you can't see from Earth.
Wow. So lucky. And I know you've seen a lot of other beautiful phenomena in space, like the aurora and air glow. What is it that makes watching a total eclipse special for you?
It's the whole package that comes with a total eclipse. It's the shadow phenomena that happens around you. It's looking at the corona around the sun. It's experiencing the reaction of all the people you're watching it with. So it's a human emotional event as well as much physics and natural phenomenology as you want to add to the mix.
Wow. Well, thank you so much, John. Any parting words?
Just get out and watch an eclipse, whether it's a total eclipse or a partial eclipse. They happen. Lunar eclipses happen. Get out and look up at the sky and think about what's going on and smile.
Thank you so much for joining us live from Spain. We're so grateful you could share your absolutely amazing solar eclipse experience with us.
You all take care.
Wow, Kelly, it's amazing to hear someone as passionate and knowledgeable as Don.
Yes, it really is, that he's seen so much and he still is so passionate about the eclipse here on Earth. It just really tells you have to see this thing.
Absolutely. So if you're looking to catch the next total eclipse, you're in luck because we have a few special ones coming up. Kelly, can you run through them with us?
Yes. So next year, there is going to be an eclipse that happens in part of Spain, throughout the northern Africa, through the Middle East. And that's going to be the eclipse of the century, the longest one of the century. So at 6 minutes and 28 seconds. That's going to be a very long one. And then in 28, we're going to have the eclipse over Australia and New Zealand. So these are going to be great scientific experiments as well as amazing experiences to experience on the ground.
Amazing. And what about the United States?
The United States, well, the next one where we'll have totality is 2044 in Montana and North Dakota, and then 2045. So it's going to be a while before we go California through Florida across the entire continent.
Amazing. So if you want to learn more about solar eclipses and NASA science, you can head to science.nasa.gov/eclipses. So Kelly, thank you so much for joining us in the studio today and answering all of our questions from our viewers. I also want to thank our guests who joined us in the studio and on the ground as well, and especially to our telescope partners and everyone who looked up with us here today. And so I think we may have some eclipse pictures from the International Space Station. I'm going to see if we can grab them now for you. If you can't, we'll be releasing them shortly after the eclipse. We're going to be posting them online soon after the eclipse, but yes, we're happy that the space station astronauts were able to see the eclipse from space. So we have something else exciting happening in just a few weeks. NASA's Kennedy Space Center Launch Complex in Florida will become the next launch site for the Nancy Grace Roman Space Telescope. This is a one-of-a-kind observatory that will help answer essential questions about dark energy, exoplanets, and much more about our solar system and out to the observable universe. The launch is currently no earlier than Sunday, August 30th. We're so excited for you to join us next time as we follow another historic mission in space exploration.
Every discovery begins with a new way of seeing. NASA's Nancy Grace Roman Space Telescope will reveal the universe on an unprecedented scale. With its powerful, wide-eyed view, Roman will map vast regions of the cosmos, seek the hidden influence of dark matter, and uncover the mysterious force driving the universe's expansion. With a wider view comes a deeper understanding.